Okay, in the previous videos, we built a full adder and a half adder, right? But in each of those cases, the addition was only one bit addition. That's what we were doing. Now, if I say, well, what I want to do is I want to do a 4-bit addition. Okay, so I have a number A3, A0, oh, sorry, A2, A1, A0. So that's my what should I say, my one number A, which is a 4-bit number, and I have another number B, which is another 4-bit number, which is B3, B2, B1, B0, and I want to build a circuit to add A and B. Now, one way to do that would be to write like a 8 input truth table and get the outputs, the sum and the carries for each of them. The sum will be a 4-bit sum and the carry will be a 1-bit thing. But as you can imagine, that's going to become very tedious, right? If you have 8 inputs, you'll have 2 to the power 8, that is 256 combinations, which would be quite difficult to do, quite tedious to do. So, is there any other way of doing it? There is, right? And one of the, if you think about how you are going to add these two numbers, I think things start to become quite clear. So if you want to add these two numbers, how are you going to add them? What you're going to do is you're going to add A0 and B0, right? And then you may have a carry. So you take the carry here and then add these three numbers. And then again you will have a carry. And then you add these three numbers, and then you may have a carry again, and then you add these two numbers, and that would kind of give you the result of the operation, right? So think about this. How do you add a carry and then 2 bits? What do you use to do that? Well, the circuit that you use to do that is a full adder, right? So you need a full adder, you need 3 full adders to do this, and you need 1 half adder to do this addition. So let's draw a circuit in that way. So let's say you have a half adder here, okay, and the input to the half adder is what? You give A0, or let me just draw it in a specific form so that it becomes a little bit more nice to look at. So you have A0 here, and let's write B0 here, okay, and then you have the sum. Okay, let's write the sum here, or maybe let me write the sum in red, so that, so sum, and that's the first bit of the sum, so let's write it as 0, and then you have the carry. Okay, let's write carry in blue, so this is C0. And then what you have is you have you take a full this, so this circuit is a half adder because it takes only A0 and B0. And then what you do is you take a full adder circuit, okay, and you give it as an input A1, you give it C0. Well, let's just redraw this C0 in a different place just to make it a little bit more clearer. So let's draw C0 going here, C0, and then you have B1 here, okay, and the output is you add these three numbers, you get a sum, the first bit of the sum, and then you use another full adder here, and the carry of this carry 1 goes to this, right? And then you give here A2, B2, and that's again a full adder whose output is going to be a number called S2, and you have another full adder built here, okay, and you can connect the carry from here to this place, and you'll have your A3 going in here, you'll have your B3 going in here, and you'll have your sum S, the third bit of the sum coming here, and you will have an output which is C out, the final carry, okay. So that makes a 3-bit adder. So I see that I've just occluded some things here, so I'm just pulling this down. Okay, so instead of doing all the bits in one stage, what we have done is we've broken the problem into smaller problems, and then we're looking at each part of the problem separately and building circuits for that. So that's how you can build adders. Hope that gives you another way of solving uh, the problem, and it's not an alternative way, but it's just an easier way of doing it, right? Instead of doing a 4-bit addition just directly and making a circuit for it, what we did was we said, let's make circuits which can do 1-bit addition and then combine those circuits and put them in order so that we can get a 4-bit addition. Hopefully that makes sense.